right? And in analysis, there are some basic tools which all of you have already mastered, like fishbone analysis, and then doing the cause and effect matrix, conducting
Yeah.
the hypothesis testing, and then you move on to conduct, the regression analysis. So what we are going to understand here in the MBB program is to spend quality time in Anova, because Anova is the test that comes in most of the projects. Any DOE or any big project you do, definitely finally that will land into Anova. So Anova is our main focus today, and also try to understand the different types of Anova. There is one-way ANOVA, there is two-way ANOVA, and there are certain situations where the ANOVA, may not be very effective. So there are modified versions of ANOVA available. They are known as general linear model. They are known as general linear model, and another one is known as Ancova, analysis of covariates. So all these things we will, but the major difference again here is the terminology. The terminology is the difference. Ultimately, finally, no, it's going to be an output is going to be an ANOVA table. You all know ANOVA table, right? So there will be factors and there will be sum of squares. There will be degree of freedom and there will be mean sum of square, just, mean sum of square, error sum of square. And we calculate F score, we calculate P value, and that's how we take a decision. So we'll quickly recall that ANOVA table also with the examples which we already studied, and we will also try to get into a new example and to understand the general linear model, right? So with that, straight away, I'm taking you through my presentation. Hope you all can see my slides,
Yes, it's
right? Yeah. ANOVA, general linear model, and also the Ancova. So we'll understand what is main effect of a factor and also interaction effect of a factor, which we already discussed in the black belt also. And then there is the based on the design, your design can either be balanced design or unbalanced design. If the design is balanced, you can definitely go for a balanced ANOVA. But if the design is unbalanced, then there is some limitation. So we need to go for the modified version of ANOVA, which is known as general linear model, which is known as general linear model. And it is also very important for all of us to understand the difference between factors and the covariate. There are certain factors which are under direct control. There are certain factors which are beyond your control. The factors which are under your control, we normally call them as factors. But the factors which are beyond your control, sometimes we call them as noise factors, sometimes we call them as covariates, right? And then there is one-way ANOVA, there is two-way ANOVA. You all know that. One-way ANOVA means only one factor you are studying. Two-way ANOVA means you are studying two factors at a time. Please note, whenever you increase the number of factors from one to two or more, your study becomes design of experiments. Till that point, it is hypothesis testing. But the moment you increase the number of factors from one to two or more, it leads to a proper, design of the experiments. We call it DOE. And then we will also see an example case with the general linear model involving factors and covariates. All right. So why ANOVA or GLM? There are different scenarios. See, our purpose is same. You need to understand. So purpose is same. Either it is ANOVA or it is general linear model or it is Ancova. The purpose is same. What is the purpose most of the time? Look at all your projects. What are you actually doing? You are checking whether there is an improvement or not. Finally, whether there is an improvement in the result or not. Improvement means the impact is the impact seen is different from the original one. Like in the case of Chandru's project, it is thermal conductivity. Thermal conductivity is improved. We had a old set of combination of factors, and then now he found a new set of combination of factor. Whether the new set of combination of factors is yielding a better conductivity or not. You are actually trying to validate difference. Difference can be between two groups or more than two groups. Normally, we say Anova is meant for more than two groups. But even for two groups, you can do it, nothing wrong. Even for two groups, you have nothing wrong because earlier two sample t-test was recommended, but Anova does the same job. So you can use the Anova for two groups also or more than two groups also. But definitely two sample t-test cannot go more than two. Right? That's how it is. And it is worthwhile to understand an example for every scenario. Maybe one of you, can you help me by reading out this scenario, this paragraph?
I can read it.
Yeah, please.
To determine whether two or more groups are different. So the
Mm.
supply manager of a plastic manufacturer purchases hardening additive from four different suppliers. The supply manager saves money by purchasing from the cheapest supplier at any given time. However, he needs assurance that there is not a significant difference in plastic hardness between additives. Sometimes knowing that a real difference exists is all that matters. Use one-way Anova to find a significant difference between two or more groups.
So what do you understand out of this scenario? Most of you would come across similar scenario, isn't it? You might want to buy something
Yeah.
and your management or your department's objective is to find out the cheaper supplier, the supplier who can supply the raw material cheaper. At the same time, you don't want to compromise on the quality of the material. In this case, it is the hardness.
Plastic.
It is the hardness. But we always know that variation exists in all scenarios. I buy raw material from two different sources. Yes, there will be difference in the hardness. Or if I buy raw material from the same supplier in two different occasions, there will be some difference in the hardness. Yes, sir.
Yes.
So a difference definitely will exist. But the point is this difference is going to be marginal or significant, isn't it? So if there is a marginal difference which is not going to affect the performance of my final product, then I have no problem going with the supplier who is selling me at a cheaper cost. Yes or no? There is a difference in the hardness, but even though I go for it, it doesn't make a difference in my final result. In such a case, it is always a good idea to go with the supplier who supply at a lower cost. Am I correct or not? You get my point?
Yes.
But
Yes.
but if I plan always with the supplier who is selling at a cheaper price, but if that is going to be very harmful to my final product, which means the difference in the hardness level has become significant and then has pulled down my final result by a significant margin, then what happens? It will lead to customer complaints and so many things. In that case, my idea of going for a cheaper supplier
Not
has
to-
created a trouble.
Yes.
So when can you actually go with the supplier who can actually supplying the product at a lower price, or when it is a good idea to stick to the one who is giving you the better quality. So this is the exact scenario for Anova. Hope you understand out of it, isn't it?
Yeah.
So in this case, in the first case itself, the choice is between suppliers, isn't it? He said there are four suppliers. So how many? What is the output? Output is probably the hardness of the material. Output is hardness of the material. The input is the factor we are studying is four different suppliers: supplier one, supplier two, supplier three, supplier four. So this is a kind of one-way Anova. Can you see that, all of you?
Yes.
Kind of one-way Anova. And there are four different suppliers. With all of them, which we look for the hardness of the material he supplies. And if there is no significant difference in the hardness of the material, then your idea of choosing the cheaper quote is really a good one, right? And that's the point. Now let's try to understand the next example to determine if any groups are the best. Chandru, can you now read the scenario?
A call center is testing 4 different scripts to see which one results is the most sales. If one of the scripts is significantly better, that is, if it produces more sales than all of the others, the call center will make that script the standard. In some cases, finding the best among the number of choices may be your overriding concern. Though this is not as simple as identifying the sample with the highest or lowest mean, you can use one-way Anova to find the group or groups that are significantly different from the rest and that can be considered statistically best.
Okay. So what is the scenario now? It's probably a telecalling job, right? A call center, and people are using some script. And now you have different types of script. And how many types it is given? Yeah, 4 different scripts. Similar scenario. And which script, when followed, gives a better conversion, more number of conversion. Telecaller will communicate based on the script. So you have 4 different scripts. So for every script, every day, how many conversions are happening? And finally, over a month, you did this exercise. It's an experiment, right? You have done. And then on an average, what is the number of conversions every day from the first script, second script, third script, or fourth script? So this is also leading to one ANOVA, isn't it? One-way ANOVA. Hope you can see that, right? And now the third one. Let us move on to the third one. To assess a specific difference exists between groups. Udayamurthy, can you help reading out this?
Yeah.
Yeah, please go ahead.
So the construction company need to choose between 3 nail guns for it is forming groups. The gun vary in price. The company wants a durable gun, but it does not want to pay more for a gun that is only a marginally better. So
Marginally
perhaps
better.
marginally better. Yeah. Perhaps the second or even third most durable tool is the best choice. Often knowing that a group have different average insufficient, and you need to delve deeper into group by group comparisons. One-way ANOVA can estimate the difference between specific groups, which allow you to make such a comparisons.
So see, this statement is very important, right? Knowing that groups have different average is insufficient. Seeing different average, is not enough to take decision. You have to delve deeper into the group by group comparison. See, sometimes when you want to buy, let's say an LED TV for your house, the durability of the television is very important, isn't it? One company might, say the television is 1.5 lakhs, but we may not go for. We just go for, let's say, one which is costing around 70,000 or 80,000 rupees. So because we know when we go for that 1.5 lakhs, probably they just give additional 1 year of warranty, isn't it? But this lower version, they give only 2 year warranty. But there is a difference. There is a difference. The one television is coming with 2 year warranty, the other one is coming with 3 year warranty. So just because they give 1 year extra warranty, we probably will not go for that 1.5 lakh model, isn't it? Because we knew that in real time, this 2 year TV with the 2 year warranty may even work better than, better for more than 3 years also. Possible or not?
Yes.
It's possible. So we are not interested in, having a marginally better product. It should be a significantly better product. Then we are okay to spend that extra money. That means if you read all the three example, finally it conveys the same meaning. Don't just look at the difference in the average. Look for whether the difference in the average is significantly different. You should be able to use the word significantly. Then only you are a Six Sigma expert. Then only you are a statistician. Otherwise, you are an average professional. Because anybody can find the difference, but only you can find the significant difference. How will you find the significant difference? How will you ensure the difference is significant? What is the tool you normally use?
P-value.
Very good, p-value. Right? Based on certain criteria, you set the p-value, and whenever that criteria is fulfilled, you will call the difference as significant difference. So these are some examples. Similarly, a few more examples to perform using a variety of data. See here, see actually, this is written mainly for your GLM, general linear model. So this is also a kind of Anova only, but then there are certain limitations for Anova, but those limitations are overcome in GLM. A beverage manufacturing company is developing a new product and they want to know its sweetener type. Sweetener type, color, and precise carbonation level. So there are three things they are checking, right? Are significantly related to the customer satisfaction. What are the three? Sweetener type, color, and precise carbonation level. So because the company is comparing groups, right? There are different formulas, right? Yeah, one-way ANOVA seems appropriate, but one-way ANOVA cannot analyze these predictors. But one-way ANOVA cannot analyze these predictors. So we go for the general linear model, which is nothing but a flexible form of ANOVA. ANOVA. And it can model multiple predictor variables, both categorical and continuous. You see here, carbonation level may be continuous, but the sweetener type is attribute. Color is another attribute. Can you see that? So different types of your predictors, if they are in different types, they are not only continuous but also attribute. So you can once you understand the scenarios becoming complex, you need to switch to flexible form of ANOVA. What do we call it as? General linear model. Now, what is the difficulty we are seeing here? The factor is not, we are not able to know, just classify whether it is a continuous or a discrete. It's a kind of mixed factor. Can you see that? See the type of sweetener, the color, and the carbonation level. Carbonation level is measurable. Am I right? Yes or no? Carbonation level is measurable. But the other two are attribute. Now you are going to find out a combination. Combination 1. Another thing is combination 2. Another thing is combination 3. But when I say combination 1, inside you have some measurable factors also, you have some attribute factors also, isn't it? And so we deal this with the help of GLM, general linear model, nothing but flexible form of ANOVA. And another case, a vacuum cleaner manufacturer is considering switching to a cheaper type of motor, but it wants assurance that the cheaper motor doesn't negatively affect the performance. The company tests vacuum cleaners with both motor types on a variety of carpet styles, right? To see how much dirt remains in the carpet, and do the two motor types have similar performance across carpet types.
I think your screen is
So-
still displaying the prior examples.
Oh, really?
Anova.
Yeah, use 1 and 2, 3 only it's showing.
Okay, now?
It's coming up. Yeah,
Oh,
now it is
now
changed.
it is okay.
Thank you.
In this case, it is a vacuum cleaner manufacturing company, and the vacuum cleaner is, removing the dirt from the carpets, right? And also there are two motor types, right? And now you also have the carpet types, different carpet types possible. You also have carpet types, different carpet types possible. So carpet is one factor and the motor type is another factor. and we really wanted to know whether it can remove the dirt very well. So the output is the ability to remove the dirt. So, but please note, you need to actually look at the data also sometimes, to understand why GLM is needed. Right now, this is only a kind of scenario for two-way ANOVA. Am I right?
Yes.
There are two factors, and we just try to measure the performance of the vacuum cleaner. So this is definitely a two-way ANOVA. You need to check. ANOVA means the design must be balanced. If design is imbalanced, then you have to switch to GLM. What is GLM? General linear model. We'll see that. And similarly, going to the another example, a construction company needs to find the best method for sealing the cracks between sections of concrete. So different concretes, now you have to probably seal the gap. So they have three sealant and two application method. Three sealant and two application method. The company wants the durable seal, but it doesn't want to pay more for a marginal increase in the durability. Perhaps the second or even the third best combination of sealant and applicant method is the right choice. If the difference is marginal, let us go for the second best or the third best. I don't want the first best. Right? But if the durability is really significant, then I can go for the first best. Otherwise, second or third is also okay. So after knowing that the groups have different averages, same thing is coming. So now, see, when you are in doubt whether ANOVA we should do or GLM we should do, better go for the GLM. That's all. Do you understand? Because GLM has got all capabilities of the ANOVA. Over and above, it has got certain additional capabilities, right? So once you see that example, then you will be able to understand. So this is also a similar to what kind of ANOVA it is? Sealant and application method. How many sealant?
3.
3.
And two application method. So how many factors you are studying? Two factors. And what is the output characteristics you are measuring? Durability.
Durability.
So what type of ANOVA it is?
Two-way.
Two-way ANOVA. So two-way ANOVA, right? That's it. And another thing, a customer support manager examines his department's extensive records and finds that the number of calls received on any given day seems to be dependent on a number of factors, such as day of the week, month of the week, the number of sales from the previous month, right? So the number of calls received in the call center depends on the month, the day, and also
Number
the
of
sales achieved in the last month. So how many factors?
3 factors.
Three factors. The manager wants to use this information to predict how many calls to expect on a particular day. So you want to build a mathematical model and try to predict how many calls will come on Monday, how many calls will come on Tuesday. Accordingly, he can have the number of executives in place so that he can schedule the appropriate number of operators for each shift. You understand the scenario here?
Yep.
So more than two factors. And now and always it's a good idea to go with the GLM. Why GLM is a good idea is whatever result I get, at least the same result I'll get in GLM. Whatever result I get in ANOVA, at least the same result I'll get in GLM also. But in certain cases, the GLM can give more accurate finding. It is like the choice between your T test and G test. You remember which is best? You all know T test and G test, isn't it?
Yes.
One sample T test and one sample G test. What is the difference?
Number of factors.
If you know population standard deviation,
If you know population standard deviation, then you go for one sample G test. In all of them, if you don't know about population standard deviation,
one
you
sample
simply use sample standard deviation in that place, which will make your predictions little less accurate. But still, you have no other options. You go for it. So whenever one sample G test is possible, you go for one sample G test. Same manner. If you are confused to make a choice between ANOVA and GLM, you can blindly go for GLM. Nothing wrong in it, right? And the difference, then what's the difference? The difference is, some difference in the method and the formula used. Even in ANOVA, I don't know how many of you are worried about the real calculations, right? We are not worried, isn't it? We normally depend on Minitab. So you just understand that a GLM exists, but then you use the Minitab and get your results. But if you really want to understand the calculations behind Anova, yes, I can help you. So after this relationship is well defined, you can predict a new response value whenever you have a new set of predictive value. That means, you can have exact number of operators in place on any particular day in any particular month, because you have built a beautiful mathematical model. See, forecasting or prediction, is a very, very important task. Most of the time, knowingly, unknowingly, you all do that work. Yes or no? And you can do it accurately only if you have the mathematical model of the situation. The mathematical model of the situation is nothing but the regression equation. So Dr. RK is going to teach you today the regression equation after the tea break. So pay complete attention so that you will be able to, really predict well and forecast well. Okay. So now again, going back to the basics. You all know what is an experiment. Am I right? You investigate the effect of a factor on your output. The factor is known as predictor. The output is known as response. Correct? If I pour water to the plant every day, then what will be the effect? If I don't pour water to my plant, then what will happen to my plant? It might die, isn't it? But when I actually pour water every single day, then I can see my plant growing very well. So now do you understand? No, understand you now by doing this, you have understood what water can do in the growth of a plant. Am I right? So this is called effect. Sometimes we call it main effect. Sometimes we call it main effect. Now the response variable is your output or Y. In my example, where you pour the water and then you observe whether the plant is growing or not. Now, what is your response variable in this case?
Plant growth.
Yeah, the plant growth, the height of the plant. You have some operation definition to measure the height of the plant, probably from the ground level until the topmost point in the plant. You measure, and that is the response variable in your case. The predictor variable is whether you pour water or not. That's all. There are only two values, two levels you maintain. Isn't it? Your experiment is to study what happens if I pour water, what happens if I don't pour water. There are only two scenarios, right? So predictor variable or factors and response variable. And predictor variable, sometimes we call them as factors and sometimes we call them as covariates. Because when you actually do this experiment, you are controlling whether the plant gets the water or not. Am I right? You are controlling whether the plant gets the water or not.
Yes.
But there are certain things you cannot control. Say, for example, sunlight.
Growth.
One day it gets less sunlight, one day it gets more sunlight. Possible or not? Am I correct?
Yeah.
Yeah, that means certain factors they are beyond your control. Either you are not interested in controlling them or you just cannot control. Such factors are known as covariates. Can you understand? But both of them are X factors. Both of them are X factor. Now, what is a treatment? A treatment is a factor with a particular level. You always have have the habit of pouring water to your plant exactly 100 ml every day. So how much water you are pouring?
100 ml.
100 ml. Now the treatment you give it to your plant is 100 ml of water every 24 hours. Do you understand? Which means if you assign the level to a factor, it is known as treatment. You might work with one factor, you might work with two factor, you might work with multiple factors. Let us consider the case of two factors. You not only pour water, you also add some fertilizer. How many factors? Two factors. And your idea is 100 ml of water you pour every day. And fertilizer, let's say you add 10 grams of fertilizer. One plant you are growing with 100 ml of water and 10 grams of fertilizer. The combination of 100 ml of water and 10 gram of fertilizer is a treatment. Do you understand now? What is the treatment we are giving to the plant? Every day we give 100 ml of water
10 grams of fertilizer.
and 10 grams of the fertilizer. So this is treatment number 1. We want to study how this treatment, work. Another plant, we might pour only 50 ml of water and still keep 10 grams of fertilizer. This is another treatment. Can you see that, all of you? Treatment number 1, treatment number 2. So what does treatment actually mean? Treatment actually mean the specific combination of factors and levels. Am I right? All of you, are you following me? The specific combination of factors and levels. In this particular example of growing a plant, there are 2 factors I am using. One is water, the other one is fertilizer. Let us say for water, I have 2 options. 50 ml of water or 100 ml of water. The 50 ml and 100 ml are known as the levels. Do you understand?
Yes.
50 ml is low level, 100 ml is high level. And fertilizer, I can add 5 grams of fertilizer or I can add 10 grams of fertilizer. Now 2 factors, each at how many levels?
2 levels.
2 levels. 2 into 2. Now 4 treatments are possible. Definitely one of the treatment can boost the growth of the plant. Do you understand? There are 4 treatment possible. Am I correct?
Yes.
50 ml with 5 gram or 100 ml with 10 gram. These are no 2 extreme combination. Low amount of water, low amount of fertilizer. High amount of water, high amount of fertilizer. The other 2 possibilities are either water is low or fertilizer is high, or fertilizer is low, water is high. Do you understand, all of you?
Yes.
Right? So now how many combinations possible? 4 combinations. So there are 4 treatments. And I really want to understand which of this treatment is good for the growth of my plant. Right? I will do this experiment and come to a conclusion, and that I will implement it in my, what you call complete field. In my farm, I will follow that after coming out with an experiment. Now, there is one more thing we need to understand known as interaction effect. So, interaction effect, when you have 2 factors, earlier we understood that water has some effect on the growth of the plant. Water has some effect on growth of the plant.
Yes.
Fertilizer also has some effect on growth of the plant. Yes or no?
Yes.
These are known as main effect. These are known as main effect. Now imagine when I give water, the plant definitely grows. Let's say it grows by 5 centimeter a week. It grows by 5 centimeter a week. Why? Because I have been giving my plant the water of how much? 100 ml every day. So at the end of 1 week, how much growth I get?
5 centimeters.
5 centimeter. The next week, what I do is, next week also I do the same thing. I feed my plant, 100 ml of water every day. But in addition, I am okay. Let us come to that little later. Now, similarly, let us understand the fertilizer. Every day, I give my plant 5 grams of fertilizer. Every day, I give my plant 5 grams of fertilizer. And now my interest is, studying about the fertilizer. So I see that when I add 5 grams of fertilizer every day, I could see my plant, growing by extra 2 centimeter. So the water is helping the plant to grow by an extra amount of how much?
5 centimeters.
5 centimeter. and the fertilizer is helping my plant to grow by an extra height of 2 centimeter. So totally, how much height, how much effect I have seen? 5 centimeter from the water, 2 centimeter from the
Fertilizer.
fertilizer. Now, another thing, I am pouring water also. I am adding fertilizer also. See, earlier I did this experiment separately in 2 different plants. One plant, I poured water. I have seen a growth of 5 centimeter. Another plant, I added fertilizer. I have seen a growth of 2 centimeter. But now in the same plant, I am adding water. I am also adding fertilizer. At the end of the week, I am able to see my plant grown by 8 centimeter now. What was our understanding earlier? Water has to give 5 centimeter growth
2 centimeter
and
from there.
it has to give 2 centimeter growth. But when I add them together, what happened? I got that extra 1 centimeter. Can you see that, all of you?
Yes.
This extra 1 centimeter is known as the interaction effect. Clear?
Okay.
In this case, we have seen the interaction as positive effect. Interaction is helping. Interaction is because pouring the water and the fertilizer together is actually good for your plant. It's actually good for your plant. Let's say, you are putting, let's say, in another combination. Suppose if the fertilizer and water are added at the same level, and finally, if the growth of the plant is found to be only 6 centimeter, not 8 centimeter or 7 centimeter, now what do you understand?
Negative
Now what do you
interaction.
understand? Here also there is interaction, but this time the interaction is
Negative.
negative. We don't know. Maybe the water is, harming. I mean, water is suppressing the effect of the fertilizer. We don't know. Water is diluting the fertilizer. As a result, diluter is not able to do the job. Can you see that? In some cases, water can allow the fertilizer to mix well, and then plants can absorb well, and plant can grow better. Can you see? Can you understand, all of you? So interaction can be positive. Interaction can be negative. When the interaction is positive, you can allow the factors to interact because that is going to maximize your results. When interaction is negative, you see to that you are not allowing the factors to interact. Try to minimize the interaction. As a result, your output cannot be pulled downwards. You will be able to manage to get a decent result. Hope all of you understand the difference between main effect and the interaction effect. See here, look at my slide. You know this player, right? Who is he?
Gavaskar.
Sunil Gavaskar, you all know. Right. And he can play well. He can hit well. And this is
Kapil Dev.
Kapil Dev. And he can also play well. Like exactly your fertilizer and the water, helping the plant to grow. And both of them can help the team to win the matches. Yes or no?
Yes.
But have you ever seen these two gentlemen opening the innings together for India?
No.
The coach has never tried this. Isn't the coach has never tried this because he know they are individually good, but together in the field, and the coach is suspecting, something negative. Maybe they cannot run, the running between the wickets may not be, as expected, or, they cannot build a big innings together. He always try to hit faster. He always, try to keep the inning longer. So this chemistry somehow, is not good for the team. That's the reason why none of the
Balanced
coach have
design.
tried. Yes?
This is kind of balanced design.
No, it's not balanced design. I'm only trying to help you understand that. The moment you understand these two factors are not a perfect match, if the interactions are not going to be fruitful for your result, better don't allow the factors to interact. Suppose what will be your feeling when you see Dhoni and Suresh Raina, both of them together in the crease? You will see the runs coming faster. RK Zarals come. Yeah.
Yeah. This balancing will be taught to you once you lose the balance after RK's class today. right? Next week, I'll take that balancing. Today, I'll unbalance you. Thank you. Please continue.
Yeah. So Reina and Dhoni together means you can see the running between the wickets very faster. All the ones they convert into twos. Can you see that? Have you seen that?
Yes.
Isn't
Yeah.
it? So that's the reason why the coach always see to that. They are getting into the what do you call
Partnership.
the pitch next to next. Probably 3, 4 down will be 3 down will be your Reina, and then 4th down will be your Dhoni or something, so that they can play together. Because in this case, the interaction is helping the team. Sometimes the left hand right hand combination the team wants. You all know. So that the logic is they know the effect of the interaction is positive or negative. Accordingly, they take a decision. So here is another easy example to understand. Painkiller medicine given to a patient and he is experiencing a pain relief of 2 hours. Now, do you understand the effect of the painkiller? The person takes the medicine, he get relieved from the pain for 2 hours. And 250 milligram, and along with the painkiller, he takes an antibiotic A. Still, he is able to get a pain relief of 2 hours, which means the antibiotic is not at all affecting the performance of the painkiller. That means there is no interaction. That means there is no interaction. In this case, there is no harm of taking the painkiller and antibiotic together. But third scenario, painkiller and antibiotic B. Now, what happens to the result? The pain relief is reduced to
1.5.
1.5 hours. Now, this is a kind of negative effect, isn't it? We expected
Yes.
a 2 hours relief, but then we actually got only 1.5 hours. Now, what happened to that 0.5 hours?
It's a
How it got vanished?
negative interaction.
Yeah. The antibiotic B actually suppressed the functioning of the painkiller. Can you see that?
Yes.
Maybe some reaction, we don't know. So this is an interaction, negative interaction. That's why, doctors sometimes they don't recommend two medicines to be taken together. They will advise you to maintain some gap, right? Something like this. At 9 o'clock, you take one medicine, and then 12 o'clock or 11 o'clock only you should take the other medicine. Because the doctor suspects, the medicines can interact and produce some unwanted effect. So all these things you need to manage if you are really concerned about optimizing your result. All of you understand? Yes. If there is only one factor, there is no question of interaction. The moment second factor comes into picture, there is a chance for interaction. Am I right?
Yes.
And so if one factor, how many effects are possible? Only one effect is possible. If there are two factors, normally we think there are two effects possible. But actually, or in reality, how many effects can be there? 3 effects. What is the third effect? What is the third effect? If there are two factors, totally how many effects? How many effects are possible? 3 effects, isn't it?
3. Yes.
The main effect from the first factor, main effect from the second factor, and interaction effect.
Both.
So totally how many effect you are getting?
3.
3 effect. But how many factors?
2 factors.
2 factors.
So far, we thought that 2 factors, so there can only be 2 effects. But now we realize, though there are 2 factors, but there are 3 effects. RK is teaching,
Synergy.
Sivakumar is also teaching. When both of them teach together, the output can be completely different from what you normally see when they teach separately. Possible. So the third effect is normally invisible to professionals, but actually it is there. Unless and until you understand the third effect, I mean the interaction effect, you cannot think of taking your results closer to the targeted value. Most of the time, you will not be able to take your results closer to the targeted value because you fail to recognize, you fail to understand the interaction effect. You understand the interaction effect and manage it well, then you will see your result moving towards the target. Clear?
Yep.
If there are two factors, just now we understood there can be three effects. Now tell me what will be the number of effects if there are three factors? If there are three factors, how many effects are possible?
Three main factors and three interactive factors.
Let us name them A, B, and C. Straight away, three main effects. Am I right? And
Yes.
A and B can interact. A and B can interact.
A,
B and C can interact. C and A can interact.
And
These are known as two-level interaction. Three factors. So far, we have understood 6 effects. 3 main effects and 3 two-level interaction effect. Now, there is one more thing known as
B level.
A, B, and C. All the 3 can interact simultaneously at a time.
Yes.
This is known as ABC. This is 3-level interaction. Totally, how many effects?
7.
yeah.
You need to optimize your result for all the 7 effects. Try to understand what A is doing, what B is doing, what C is doing, what AB is doing, what BC is doing, what CA is doing, what ABC is doing. If everything is positive, don't worry. You allow every factor to interact. If some of them are negative, try to manage. Understand? Clear?
Yes.
Yes.
Now you need to understand fixed factors and random factors. What are fixed factors and what are random factors? Let's say in our training program, in any training program you come, you see GSK and you see RK. Am I right? You are seeing regularly, isn't it? Right? So they are fixed factors. The factors are fixed. You join any program in Mission Excellence, you obviously learn from GSK. You obviously learn from RK. You learn from Vinod. You learn from Vivek. You all have experienced. The factors are fixed. Let's say you join another program, you don't see any of us. And randomly, one faculty is coming and, conducting classes. You have never, expected him. Now the factor is random factor. Do you understand?
Yes.
Yes.
Let's say you are studying about the performance of a boiler and the boiler temperature can range anywhere from 600 degrees Celsius to 800 degrees Celsius. Now the investigator, he decides the boiler should be run at 600, the boiler should be run at 700, the boiler should be run at 800. Now the boiler temperature is decided by who? Investigator. Now the factor is known as fixed factor. Am I correct?
Okay.
Yes.
Suppose if the boiler is running every 1 hour once, you are going and measuring the temperature. Do you get exactly 600, 700 and 800?
No.
No.
It will be 605, it may be 725, or it may be, 800.43. What some value it will come. That value you are recording. Now your factor is,
Random
Random.
factor.
now do you understand what is fixed factor and what is random factor?
Yep.
Clear? Let's say you are studying about the functioning of a call center. The functioning of a call center. And first shift, second shift, third shift. And every shift, first shift, you collect data from a particular call center executive. Second shift, a particular call center executive. Third shift, another particular call center executive. And the executive is chosen by the investigator, which is you. Now, what is this factor known as? Is it a fixed factor or random factor?
It's fixed.
Come on, tell me. It's a fixed factor or random factor? You are studying the performance of a call center.
So fixed.
Fixed factor. You are choosing. First shift means
Yeah,
you always
just
study
writing.
Ramu. Second factor means you always study Somu. Third factor means you always study Ramesh. Now the factor is fixed.
Yes.
But 50 executives are sitting on the desk. Now you randomly select one of the executive and record his performance, record the data from him. Now your factor is random. Hope all of you understand whether your factor is fixed or random. How to differentiate, right? And another thing, crossed factor and nested factor. Crossed factors and nested factors. You already know the gauge R&R study, crossed study and nested study, isn't it? See here, two factors are considered crossed when level of factor occurs in combination with other factor. Do you understand? Two factors are crossed when level of factors occur in combination with other factors. Which means, imagine you have two machines, machine number 1 and machine number 2. Now, what is the factor I'm studying? The machine.
Yeah, machines.
I'm studying about the machine. The factor is, in this case, whether my factors are crossed or nested. Machine number 1 and machine number 2. And I can run machine number 1 using the operators Mark, Stephen, Amy. I run the machine number 1 and who are the operator? Mark, Steve, and Amy. Machine number 1 run by Mark is first combination. Same machine number 1 run by Steve, another combination. Machine number 1 run by Amy. That means a factor with its corresponding level is one combination. This is what we call it treatment, isn't it?
Yes.
All right. So this is first three combinations are possible. Now, for machine number 2 also, when I want to run the machine number 2, if I use the same operators, Mark, Steve, and Amy, the factor is considered to be crossed factor. Because the levels are same. Because the levels are same. But machine number 1 and machine number 2 are different. But there is one more possibility. I run machine number 1 by 3 set of operator, and another three operators will be used for running machine number 2. That means the factors are nested. What? Why? See, sometimes why I have to do like this? Because the machines are in different place. Let's say one machine is in India, other machine is in Germany. But I want to study, compare the machines. Now, obviously, my study has to be, tell me, obviously, my study has to be
Nested.
nested. We all know the crossed is better because that can give a better comparison of machine 1 and 2, isn't it? But I'm forced to use the nested one. So you see to that, the operators are similar. See to that, the operators are similar in terms of the skill level to operate the machine. But they are not identical. Hope you understand. All right. So now you also understand another meaning, crossed factor and nested factors. Here operators are nested under machine. Can you see that?
Yes.
Operators are nested under machine. Now covariate. Covariate means there are certain factors which we are not interested in studying or which we are not able to control. For example, in the training program, you can attend the class through mobile phone. You can also attend the class through laptop. Am I right? Which is better?
Laptop.
But we are not able to control. But that has an impact on the final outcome of the course, isn't it? But we are not able to control. So such factors, I should give it a separate name. They are not they are not just the factors, they are covariates. You understand? They are covariates. They are known as noise factors. In spite of our best efforts, sometimes people are not able to clear the exam. We don't know why, isn't it? Why? Because certain factors we are not able to control. Say, for example, they attend the class on their own willingness. Some people, they attend some class, they don't attend some class. That's definitely a factor. The effect is also significant, but unfortunately, we don't have control over it. So I should call it as a noise factor or a covariate. Do you understand? So attending through the laptop is good. Attending all the classes is good. Trying out your all the assignment is good. Everything is good. But then we don't have control over many things. We simply call all of them as covariates. And see, the covariates may be continuous sometimes. Say, for example, the room temperature under which you currently sit, that room temperature is also and some no maybe comfortable to the learner, sometimes uncomfortable to the learner, isn't it? If it is uncomfortable, probably you will not be able to focus well, isn't it? So these factors, this is what we call it as covariates. Sometimes what we do is we include the value of the covariates while performing the experiment. But sometimes we just don't include. If you don't include them, then they are considered simply the noise factors. Then they are simply considered the noise factors. Whatever effect we are not able to understand, we will call it as noise effect. We'll call it as noise effect.
I see.
But sometimes what we do is, while performing the experiment, even though we have no control over the covariates, we will record the value of it. Say, for example, I will ask, Justin, are you attending through mobile or laptop?
Yes.
Laptop. Laptop. And Chandru, you are attending through laptop. Am I right?
Yes, yes.
Udayamurthy, how about you?
Laptop.
Attending through laptop. And Rahul Ghosh, how about you? You need to tell us. And so,
Mobile.
Mobile. So now that the covariate is also recorded, I have no control over it, but then I have recorded. If this is recorded, I can make an attempt to understand the effect of this covariate also. I have Justin, on the laptop, Udayamurthy on the laptop, Chandru on the laptop. There are 3 people on the laptop and Rahul Ghosh on the mobile. Or maybe, let us consider, some number of students on mobile, some number of students on laptop. Now I conduct the exam right after the completion of the session. Now I have a set of marks scored by the people who attended on using laptop. I also have set of scores for people who attended using mobile phone, isn't it?
Yes.
If I could see a difference in the marks, if I could notice the difference in the average marks scored by the people
Laptop
used
teacher
mobile
computers.
and people used laptop, can I attribute this difference to the device they have used to sign in?
Yes.
We can attribute definitely to certain extent because there can be many other attributes, many other covariates also. I'm only talking about one covariate. But definitely I can attribute, statistically I can attribute. The difference is because of the difference in the device used for attending the session. That way I can explain. Maybe if you have attended using laptop, you would have got this many extra marks, isn't it? So that means by calculating my data in a particular manner, I can even understand the effect of the covariates. Possible or not?
Yes.
I just don't want to ignore them as noise. Rather, I will study their effect as covariate. I will clearly tell the effect of the covariate is this much. All right? And such a study is known as Ancova. That's all. Clear, all of you?
Got it.
Everything is understood?
Yes.
Yeah.
Yes.
Let us say
yes.
you are studying about the sales, right? You are studying about the sales made by your sales team. And your sales team is reaching to so many people. And at the end of the sale, at the end of the campaign, you also somehow you captured the age of the customers. Do you have control over the age of the customers?
No.
People simply come and then buy from your website. But the age is, The age of the customer who are visiting your website has a significant effect on the sales achieved. Am I correct? People in the earning age, they make buying decisions very faster. People who are retired, they simply look at the website and don't buy much. People who are yet to earn, they end up not buying anything, isn't it? So the age of your audience is a factor that has an effect on the sales achieved, but you don't have any control over the age. Now, what should you do to improve your sales? Create traffic with the audience who have the earning age, isn't it? Who have the tendency to buy. So how do you come to this kind of logical conclusion? Because you studied the effect of the customer's age, yes or no?
Yes.
And from the trend analysis.
Very good, yes. So this is the advantage of studying covariates. And there is no point of simply ignoring all the covariates as noise. Hope you all understand, no? How the covariate is also helping us in making some logical decision. So ambient temperature is a covariate while controlling the corrosion using different beam types. In construction industry, there are different metal beams. You are studying the corrosion rate, and you apply some chemicals, etc. Studying something. But ambient temperature is another important factor, which you don't have any control, isn't it? The beam can be used wherever they want. So the effect of the ambient temperature comes under the covariate. Hope it is very, very clear to all of you so far. If the terminologies are clear, then the analysis is 5 minutes job. Same method. You feed the data, you go for the Anova or GLM. When you go for the GLM, it will ask you whether your factor is fixed or random. You have to declare. Now you know how to declare, isn't it? That's what. So similarly, your design can be, whenever you conduct a study, whenever you study factors, 2 or more factors at a time, the study becomes design of experiments. If it is 1 factor at a time, the study is known as
Experiment.
hypothesis testing. You study 2 or more factors simultaneously, the study is known as design of experiment.
Okay.
So hypothesis testing versus DOE. Hypothesis testing means 1 factor at a time. DOE means multiple
More than
factors,
2 or more.
more than 1 factors simultaneously. We study more than 1 factor simultaneously, we call it DOE. Imagine a scenario where you study multiple factors. Then it becomes DOE. Then you need to have a design for the experiment, right? Test design or test matrix you should have. Now let's say there are 2 factors. There are 2 factors like the sealant and then type of application. Sealant is 1 factor. Type of application is another factor. And we are studying the durability of the seal. Do you understand? There are 2 factors and you have 3 types of sealants. How many types of sealant available? 3 types of sealant available. An application method, 2 methods available. Now, how many factors we are studying simultaneously? 2 factors. One is
seal.
type of sealant. Another one is
Application
sealing method. And type of sealant, how many sealants are available? 3 sealants.
Sealant, yes.
These are known as levels. 3 levels for the sealant and application method 2 levels. Now, how many combinations are possible? 3 sealant, 2 application method. 3 into 2?
6.
6 combinations are possible. 6 treatments are possible. Now, every combination is known as a treatment. Every combination is known as a treatment. 6 treatment available. So every treatment you have to conduct some number of times. Say for example, sealant number 1, application method is, let's say, spraying. This is a combination. Let me say I do this for 3 times. Now next combination. Same sealant number 1. Instead of spraying, now I am going for dipping. This also I am doing it for 3 times. For all 6 combination, exact number of times I am conducting the experiment. Now my experiment is balanced design, which means replications are equal throughout your experiment. Every experiment is replicated how many times?
3.
3 times.
3 times. Now this is known as balanced design. Suppose if the replications are not going to be constant, for some reason, I don't know. Certain experiment 3 times, certain treatment 4 times, certain treatment only 2 times. Now my design is unbalanced. All of you understand?
Yes.
So
Is
you
it
also
depending
now
on the
understand.
factors?
Sorry, just a quick question. In this example, what you mentioned, so we have three factors and then we have a 2 applicable method, right? So now
Now we have three types of sealants.
3 type of sealants, 3 levels, and two type of applicability.
Application method 2 types.
So when we do a combination, don't we consider the interactive effect also, because we are just considering only 6?
No. Treatments are 6 only. Interaction
Treatments.
comes when you talk about the effect.
Okay.
See, effect is different, factor is different, level is different. Now we are talking only about the factor and the level combination. So everything will have an effect. When you talk about the effect, then interaction comes. Now, based on the factor level combination, every combination, how many number of times you want to
3
repeat?
times.
Exactly 3 times you repeat, then now your design
Balance.
is balanced. If you keep different numbers, then it is unbalanced.
Okay. Got it.
See here one example. 3 types of primer. Primer 1, primer 2, primer 3. 2 types of painting method, dipping and spraying. Now primer 1, dipping combination. How many times you did the experiment?
3 times.
3 times. This is known as replication. This is known as replication. Can you see the replication always remaining 3?
Yes.
So now can I call this design as balanced design?
Yes.
Now you check here, is this replication always 3?
No.
No.
3 sometimes, 4 sometimes, 4 sometimes, 3 sometimes, 2 sometimes. So this is unbalanced design. So for you to perform Anova, your design must be balanced. Your design must be balanced. If it is not balanced, you need to go for GLM. What is GLM? General Linear Model.
Model.
Okay. So determine whether the mean of 2 or more group differ significantly. You go for one way ANOVA, right? When the experimental design is balanced, you can go for balanced ANOVA. But when the experimental design is unbalanced and include random factors, covariates, and mix of crossed factors, nested factors, your situation has become complex, right? Now you go for the flexible version of ANOVA, which is known as general linear model. But all of this are univariate analysis. We are trying to maximize only one output through our project. We are trying to maximize only one output through our project. Sometimes you may want to maximize 2 different output through a single project. In that case, it will be known as multivariate analysis. Say, for example, I want a higher surface finish also. At the same time, the material removal rate should also be faster. I want material removal rate to be faster and higher surface finish to be faster. I want my work to be completed faster. At the same time, I need accuracy also. Right? So likewise, but when you want to go to this area, multivariate analysis, you should start learning the matrix algebra. Already mathematics is little difficult, but now matrix mathematics, right? So instead of numbers, you will be having matrices. All right. For example, if you look at your calendar, monthly calendar, have you seen the monthly calendar? Monday, Tuesday, Wednesday, Thursday, and then some dates are available. That's an example of a matrix. That's an example of a matrix. So, same manner, how can we add two matrix or subtract two matrix, multiply two matrix, and divide two matrix? If you could learn that, you will be able to understand multivariate analysis also. In such a case, your analysis will be known as, can you read this out?
Anova.
Anova, multivariate analysis of variance.
Yeah. So when needed, you can get into that. Hope you all understand. Right? So far, good?
Yes.
Okay. Now look at this first graph as well as the second graph. The first graph is a comparison between three groups. Here also three groups. And when you compare the average here, you compare the average here, you compare the average here also. What do you understand? Here the difference in the average is marginal. Am I right?
Yes, margin.
But here the difference in the average is
Different.
significant.
Significant.
Significant. Okay.
This is what exactly Anova is doing. When the difference is marginal, it is as good as saying though no difference. It is as good as saying no difference, isn't it? But when difference is significant, that means one of the average is significantly better, statistically better. You can take a decision based on your observation. But here, it is better to conclude as no difference. You understand? In this scenario, you should not reject the null. But in this scenario, you can reject the null. You understand? The right side, can you reject the null here? Can you reject the null hypothesis here? No, don't reject.
Oh, yes.
There is no
Because
difference.
null always says, there is no difference. The diagram is also telling the same thing.
Yes.
There is only marginal difference. But here, there is a significant difference. So you boldly reject the null. So what is actually allowing you to reject the null? What is actually making you to reject the null? You look at the spread of each distribution here. Can you see the spread is too much in each case? The spread
Yes.
for the black color distribution is too high. Can you see that? It is ranging from -10 to +20.
Yes.
This is called variation within your data.
Mm.
This is called variation within your data. But when you come on to the left side, the first distribution, it is ranging from 2 to 4 only. -10 to 20, the spread is too much. But 2 to 4, the spread is too less. When the spread is less, it is easy for you to understand which average is better. When variations are minimal, it is easy for you to decide based on the average. So don't just look at the difference in the average. Side by side, you should check what is the amount of variation within your data. If the variation within the data is low and you still notice a difference in the average, this is what is known as significant difference. Do you understand, all of you?
Yes.
If there is a difference in the average, but the variation is too high, this is what is known as marginal difference. When the difference is marginal, don't reject the null. When difference is significant, you reject the null boldly. Clear, all of you?
Yes.
This logic is statistically denoted as F score. Whatever logic we are saying, the logic is statistically known as F score. What is the logic? Difference in the average. You see here, variation between the groups. Variation between the group means difference in the average. Variation within the group means spread in your data. That ratio is known as F score. What is numerator? Difference between the averages. And difference within the group. The ratio is known as F score. Whether based on the F score, you can understand whether the difference is marginal or the difference is significant. Clear? This is the logic behind Anova. And so see here decision rule. If the calculated F score is more than the permissible value which is tabulated, then only you should reject the null. Whenever if it happens to see the calculated F score more than the tabulated F score, you can understand the difference is not marginal, the difference is significant. And so you reject the null. Hope it is clear.
Yes.
So now simple example, this I have already taught you in some of our lower level trainings. The scenario is you are comparing the performance of 3 vendors based on the time they consume. Based on the time they consume a completed task. So the output variable is transaction time. And you are comparing vendors A, B, and C. How many vendors? 3 vendors. So the study is one-way Anova. The study is one-way Anova. So each vendor T1, T2, T3, their performance data is available. You see here the average, the total time consumed by vendor A is 685. Total time consumed by vendor B is 731. Total time consumed by vendor C is 713. Now who has consumed more time?
Vendor B.
T2.
And then who has consumed lesser time?
Vendor
A.
Vendor A. So normal conclusion is vendor A is found to be better because it takes less time to complete the task. Isn't it?
Yes.
He could perform faster. So now normally we tend to retain vendor A and then penalize vendor B and C. Maybe we may cancel the contract or something, isn't it? But still, my only doubt is whether the difference, whatever I see here, is marginal or significant. Do you understand? You don't know what kind of vendor they are. You don't know what kind of work they are doing. How can you say this is significant or this is marginal? Because you are not an expert according to this particular data. Am I right or no?
Yes.
If I give blood report of 100 people, are you the right expert to read the blood report?
No.
No. Whenever you are not an expert, but still you want to understand whether the difference is marginal or significant, you can use statistics. Even though you are not a domain expert, still you are able to make a decision whether the difference is marginal or significant. That is how you are going to stand out from other professionals. Do you understand? Whether you are not an expert in a particular domain, even then you can definitely conclude whether difference is significant or marginal. Marginal means there is no difference. As good as saying that there is no difference. Significant means
There
More
is
A
difference.
is significantly better. You can definitely cancel the contract of B and C. And A will definitely will will definitely honor your decision in the future also. Right? But now look here, this is the Anova table, you all know. Am I right? This is the Anova table, you all know. And degree of freedom, you know how to calculate? How many vendors here?
3 minus 1.
3 vendors.
So 3 minus 1 is 2. Totally, each vendor 120 transaction you have studied. So total number of transaction is 360. 360 minus 1 is 359. Total degree of freedom is 359. And error degree of freedom is 357. Because 359 minus 2, 357. And now with the help of the sum of squares, degree of freedom, you calculate something known as mean sum of squares.
Okay.
What is sum of squares? What is a square, you know? What is square? If I give a number, will you be able to square it?
Yes.
And if I give 10 number, will you be able to square and then add them together?
Yes.
That is known as sum of square. Right? And a detailed understanding, I will share the Excel sheet behind all these calculation. You can just go through and ask me the right question, how this has come and how that has come, then I will be able to explain, right? So sum of square is calculated, degree of freedom is calculated. Sum of square divided by degree of freedom will give mean sum of square. 8.9 divided by 2. Can it be 4.5?
Yes.
Yes. And the 4.5 divided by 1.95. Can it be 2.28?
Yes.
This is known as F score. This is known as F score. You remember earlier also we said difference between the group, different divided by difference within the group. Now all of you please open the Excel file and please type this so that you can find out the corresponding p-value for an F score of 2.28. Please open an Excel sheet. In any cell, you please type this formula equal to F dist, open the bracket, type your F score value, which is 2.28, and comma, type the degree of freedom of the factor, which is 2, comma, type the degree of freedom for the error, which is 357, and then you close the bracket.
0.103.
Are you able to see the same 0.103 here?
Yes.
Yeah, this is one way of generating p-value from the F score. You can do the same thing using Minitab also. We'll see that, right? We'll see that. If you could remember, you can see that. So now, if p-value is 0.103, is it more than 0.05 or less than 0.05?
It's more than 0.05.
So, fail to reject. Fail to reject means the difference is marginal or significant?
Marginal.
Marginal. If difference is marginal, would you like to take the risk of making a decision using the data?
No, there is no
No,
decision.
no.
Yes.
Don't take any decision now because you are not able to reject the null. Now the study is over. Practical conclusion is continue with all the vendors. That's all. Clear?
Got it.
This is your Anova. Please note always when you are performing Anova, before generating the p-value and making the conclusion, one important prerequisite is you must study the variance in each group. Because one of the requirement for performing Anova is the variances in your data must be equal. What is the precondition? Variance in your data. Every column of data should have same variance. Having a marginal difference is okay, but significant difference should not be there. You understand? So, variances are equal. So, you are performing another hypothesis testing to understand whether the variances are equal or not. Now, how many groups? 3 groups, right? So, 3 variance. Variance means square of the standard deviation. You can see here.
ABC.
This is known as Bartlett test. This is known as Bartlett test. And the Bartlett test generates a p-value of 0.723. That means what? The difference is marginal. If the difference is marginal, you can conclude that variances are equal. Now the requirement is fulfilled. Clear? Another thing is, another underlying assumption is the data collected by you are normal. You perform the normality test, Anderson-Darling test. And tomorrow you have a session to understand how to check normality of a data. And if data is not normal, how to convert that into normal again. I think that was done already, isn't it?
Then yes.
Yeah, that was done, right? Yeah. So now you perform the normality test. And for A as well as B as well as C, look at the p-value. All of them are more than 0.05. When all of them are more than 0.05, you look at your null. What is your null? Data are normally distributed. Since it is more than 0.05, you can't reject the null, which means your data are normal. So again, this requirement is also fulfilled. For performing Anova, data must be normal, variances must be equal. Both conditions are fulfilled. Hope all of you understand here. This is a classical example of one-way Anova. Clear? And this is classical example of two-way Anova. Because here you are studying about primers and painting method. See here, output variable is the adhesive force or adhesion force of the paint. Because all my components are going into aircraft, engine or aircraft application, the paint quality is also important. The paint surface should not come out. It is going to operate, maybe, used in aircraft component. And so the adhesion force should have the desired quality. And the adhesion force depends on primer and then application method. The company want to know whether they can have the flexibility in using 3 types of primer and 2 types of painting method. If the differences are marginal, they can include the flexibility in their work. If the differences are significant, the company is not supposed to have that flexibility. Am I right or not?
Yes. Yes.
Very good. So 2 factors, two-way ANOVA, and each one factor, there are 3 levels possible, primer 1, primer 2, primer 3. The other factor, 2 levels possible, dipping and spraying. And now this is how the experiments are conducted. Now find out whether it is balanced or unbalanced.
It's balanced.
Balanced.
It's balanced.
Okay,
And now look at the way the data is used here. Some calculations are done here. Why these calculations are done? To generate the ANOVA table. To generate the ANOVA table. Should I explain any one number here? For example, 4.58.
Yeah.
Are you willing to listen?
Yes, yes.
Yeah, 4.58.
Hmm.
See here, 4.58 is calculated here. You can see here. What is this 4.5 represents? Primary effect. 4.58 represents effect of the primer. Okay. And in order to calculate this, you have to select the row total. You see here, total of the first row, 28.7. How this 28.7 has come?
Yeah, total.
Sum of
We had that all the
6.
rows.
All the 3s.
Yeah. I painted the component using primer 1 and dipping. And now the adhesion force is measured. Adhesion strength is measured 4. I did this for 3 times. Similarly, with the same primer, spraying 3 components. They're also measured. Totally, there are 6 components. All the 6 I totaled. Now, what is the common thing in this total? In all these numbers, primer 1 is used. Am I right?
Yes.
Similarly, for primer 2, 34.1. Here, the common thing is primer 2 is used. Here, primer 3 is used. Can you see that, all of you?
Yes.
Now, the difference in the number can be attributed to the different types of primer. Am I right or no? The difference in the numbers can be attributed to the different types of primers. Yes or no?
Yes, yes.
Yeah. So, each number is squared. Each number is squared and then added. Each number is squared. That is known as squared sum. Do you understand? Each number is squared and then added. That is known as squared sum. And each number is a sum of 6 experiments. Am I right?
Yes.
So you divide by 6. So you divide by 6. Then you subtract a factor known as correction factor. And how the correction factor must be calculated? GT means grand total. Can one of you tell me what is grand total here?
89.8.
Very good. You have done 18 experiment. All 18 values you have to add. That is known as grand total. You need to square that. Total and divide by number of experiment, which is 18. Now the resulting value is correction factor. You subtract that value. And now what will you get? 4.58. All of you now tell me, do you understand how this 4.58 has come?
Yes.
This number, is an indicator of primer effect. Similarly, painting effect of the painting method can be estimated. effect of the error can be estimated. Whatever effect you cannot account, you cannot assign. The difference is considered as error. You can see here. So all these numbers calculated only participates here. You can see. Can you see that 4.58? 4.90. What is 4.90? Effect of the painting method. And error is how much? 0.98. Can you see the 0.98 error?
Yes.
Interaction is also coming.
0.24.
In order to calculate interaction, see here, the first three numbers is summed here. 12.8. The first three represents primer 1 dipping combination. The sum of first three represents primer 1 dipping combination. The sum of these three represents what?
Primer spray.
Primer 1 spraying
Spraying.
combination. Likewise, 6 combinations are possible. Right? 6 combinations are possible. These 6 numbers, if there is any difference in this number, and that can help you to understand the interaction. That can help you to understand interaction. See here, primer 2, when it is going with the dipping, this is the force. But the same primer 2, when it is going with the spraying, can you see some improvement in the adhesive force?
Yes.
That means here interaction is little boosting your result. Can you see that?
Yes.
So we work with the number in a particular manner to understand whether there is an impact or not. Same topic, if it is, let's say RK is going to teach regression today. And the same topic for suppose, Vinod Shankar can also teach. Isn't it? And now the difference in the, in the marks scored by you can help me to understand the caliber of the faculty. Yes or no?
Yes.
The difference, cannot be attributed fully to the caliber of the faculty, but definitely that can indicate. That is my point. Right? I will carefully subtract the effect and add some effect to exactly understand, the caliber of the impact of the caliber of the faculty. So same thing we are doing here. So the interaction effect, everything is listed here. Once you fill up this, the remaining is a very simple question. You all know how to fill up the degree of freedom, am I right? Can somebody tell me how the 17 has come here?
Addition of all degree of freedom.
Number of experiments is 18. 18 minus 1 is
Total number of experiments minus 1. Total number of experiments minus 1.
1.
And can somebody tell me how the degree of freedom for interaction is 2?
There are 3 interactions, so 3 minus
3
1.
minus 1.
minus 1.
No, there are 3 interactions. No. There are no.
6
See here,
interactions.
no. So that's not the way to calculate the degree of freedom. The interaction degree of freedom is nothing but the product of the degree of freedom of the factors concerned. Primer and method interacts. So 2 into 1, 2.
2 into 1, okay.
Oh, okay.
Okay.
And how to calculate the error degree of freedom?
Total minus primer method and interaction.
Very good. Total minus the other degree of freedom, which is pi. 17 minus pi is 12. Now you understand everything.
Yeah.
Now
Yes,
what is
yes.
4.9 divided by 1? 4.9. What is 4.58 divided by 2? 2.29. What is 0.2 divided by 2? 0.12. What is 0.98 divided by 12? 0.08. I already taught you, with the help of
This square.
F score. How to calculate F score? Mean sum of square divided by error sum of square. 2.29 divided by 0.08 will give you 27.85. 4.9 divided by 0.08 will give you 59.7. 0.12 divided by 0.08 will give you 1.46. Now you convert all of them into p-value. Convert all of them into p-value. You know the formula, isn't it? You remember? Excel file, F dist, open, F score, degree of freedom for the factor, degree of freedom for the error.
Yeah.
Now look at the p-value. The first two p-value are less than 0.05, which means the effects are significant. The difference is not marginal, difference is significant. Primer has got a significant effect on the adhesion force. Do you understand?
Yes.
Painting method has got a significant effect on the adhesion force, but interaction, it is not significant. To a certain extent, you can understand the same by referring to the data. Look at the primary effect here. Do you see a boost in the adhesion force?
Hmm.
Yes.
Which is the primer that is giving you more adhesion force?
Primer 2.
Similarly, do you see a boost in the adhesion force when we change the painting method?
Yes. Spraying.
Which is good for you?
Yeah.
Spraying is good. And look at the difference. How much it is? Can you see a difference of 9.4 here?
Yes.
Nine.
Can you see a difference of around 6 point, close to 6 here?
Yes.
And here also there is a difference. Can you see? But the difference is maximum is, almost close to each other. Can you see the number?
Yes. Almost close
Right? Almost close, but it's only rough idea I'm giving you. So to understand whether the difference is marginal or significant, you look at the corresponding p-value. This is low, so main effects are significant. But interaction effect is
marginal.
marginal, so don't consider interaction in this case. So you are visualizing the scenario. When I use primer 1 and the blue color line represents dipping, primer 1 and dipping, on an average, the adhesion force is 4.25. Primer 2 dipping, on an average, the adhesion force is 5.25. Primer 3 adhesion force, the average adhesion force is 3.75. And for primer 1 and dipping, the average adhesion force is 5.25, 6, and 5.25. Where is my adhesion force maximized? Primer 2,
In by a spraying method.
spraying method. Since primer is also significant, painting method is also significant. Company cannot have the flexibility to choose any primer or any painting method they want. That is not permitted. Simply because there is going to be a significant difference in the adhesion force. The flexibility is not allowed. So the company is advised to use the combination of primer 2 and spraying only. Clear?
Yes.
So far, what we understood is Anova. The analysis wise, everything will be same, and this is how the Minitab report will look like. Right, the same thing, in plotted in Minitab, we get the same values in Minitab also, which I have explained manually today, and the decisions are taken. So what I do is in the next class, I will take you through some examples of general linear model, but however, the logic remains same. The logic remains same. So, but in Minitab, there is a separate path for performing general linear model for performing Anova, which I will teach you. Maybe that will take only another 10-15 minutes, but I don't want to disturb the next session because that is also equally important. So as per the schedule, it is supposed to commence by 7:45. So I stop here, and then how to perform all of these in Minitab, and also understand where to analyze for the general linear model, and that with appropriate example, maybe another 15-20 minutes needed. That I will do it in the next class. Any questions on so far? Everything is clear?
Yep. Yes.
Okay, fantastic. So we just have to stop here for your